All right, how's everybody doing out there? This is Mr. Muscarella coming at you, and we're going to take a look at solving trig equations review problem number 4. All right, so here in problem number 4, it says solve the trig equation in the interval 0 to 2 pi. We have sine of 3 theta equals -1. Now with this, it doesn't seem that bad, but what you want to kind of do is ignore the 3 theta for a second. Just think about where is sine -1 on the unit circle. So if you were to think about that, sine is your y coordinate. Where's that -1? And that is in one spot down here at the location of 3 pi over 2 or 270 degrees, because the coordinates there, of course, are 0, -1. Now from there, what we're going to do is we're actually going to play with this 3 theta part, and we're going to set that equal to 3 pi over 2. Now to get all the way back around to 3 pi over 2, of course, we're going to have to add 2 pi. So that's going to give us 3 theta equals 3 pi over 2 plus 2 pi k, where k is an element of the set of integers. Now I want to solve this for theta, which means I've got to divide everything by 3. That gives me theta equals pi over 2 plus 2 pi k over 3, again, where k is an element of the set of integers, k-e-z. From here, what I like to do to kind of get everything set up for me, I like to get a common denominator. Then it'll be easy for me to test out different values for k. So when I'm going to test out values for k, first thing I'm going to do is I'm going to let k be 0, of course. And when I plug that in, of course, the second term is going to give me 0, so I'm just left with 3 pi over 6. Now be sure you reduce that to pi over 2. Again, I'm going to substitute k having a value of 1 this time, and when I do that, I end up with a value of 7 pi over 6. Substituting k equals 2, I have 3 pi over 6 plus 4 pi times 2 over 6, giving me a result of 11 pi over 6. When k is 3, now I'm at 15 pi over 6. This is what you have to take a look at right here, is this particular value. Because when you're going from 0 to 2 pi, if we've got 6 on the bottom, so 2 pi is the same thing as something over 6, and since 6 is my denominator, I would want that to be 12 pi. So anything 12 pi or more over 6 is going to be outside of that range of 0 to 2 pi. So 15 pi over 6, thank you for playing, but you are not a solution, and we don't have to test any more values of k. So from there, we write down our 3 solutions: pi over 2, 7 pi over 6, and 11 pi over 6. So that's it for this video. I'll catch up with you guys later for example number 5. Peace out.